Welcome to video 13 in a series of introductory videos for the InventorCAM CNC programming software. This video topic is the HSR Toolpath. So HSR is another target-based roughing toolpath from InventorCAM, and it's relatively simple to program. It's similar to some of the other 3D toolpaths you would have seen in this series of videos. So let's begin with the very first option that you'll see when you open up the HSR toolpath, and that is the HM roughing. So the way we program this is we start with the geometry, much as with all the other InventorCAM toolpaths. You'll see that the geometry is preloaded to be the target. So the target is actually the solid you've selected when you first define the part. Go to Tool. In this case, I'll be using a 1/2-inch flat end mill. You provide the fees and speeds for this toolpath. Under constraint boundaries, this is similar to the working area you would have seen in other toolpaths in the series of videos. The constraint boundary works the same way. Basically, we either take an automatically generated boundary, which in this case would be the outside edge of the part, or we can switch to create manually, and we have many options here to actually define the working area. So for this part, I'm actually going to use the automatically generated one, but to give you an idea what you'll do with the user-defined boundary, I can click on New, and it brings me to my chain selection list, the same chain selection list you would have seen in the profile or the pocket videos in this series. And all we do is just choose contours off of the solid that we want to represent the fenced off area. Once we decide what area we would like to fence off or just kind of machine only in that one area, we can decide what type of boundary it is here. And in previous videos, you would have seen this. It's external, internal, centered, and tangent. Essentially, we will machine what's inside of the contour, but we'll reposition outside that contour or stay within that contour depending on which option we select here. For a review on that, I would refer you to the 3D iMachining video. So like I said, we'll just go to create it manually. Under passes, we'll see the main control center of this toolpath. So as a roughing toolpath, I'm leaving behind 10 thou on the walls and the floor. My step down, I've decided to just put it as 100 thou. My step over, I can control that either by an actual number or I can put in a percentage of the tool diameter. In this case, I've decided to put it at 300 thou. My step down type, as a 3D toolpath, I can leave it as constant, meaning that it'll step down across the part, down in the Z direction with that 300 thou step. Now, I can also switch this to constant and flats. And what that'll do is it'll do the same thing as constant, but it'll also add additional passes to take care of any kind of horizontal areas. Over on the right side here, our limits. This is where we would control the levels of this toolpath. So Z top and Z bottom are essentially just upper level and lower level, like you would have seen in the other basic toolpaths. Here, we're basically just telling InventorCAM the envelope that we'd like to work in. As a target-based toolpath, it's going to look at the entire target, but it'll only work between these two levels. So I basically have chosen the top face right here and the bottom face of the part. On the top face, I've just added an additional 20 thou just to account for maybe that's not exactly the top face. Maybe there's a couple of contours that just kind of pop up a little bit. Now, in terms of the step over type, we'll see that there's three options here. Essentially, just going down the list, core is a step over that goes from the outside in. If I select that option, you'll see that it actually does kind of like a spiraling toolpath or a contour toolpath, starting from the outside and works its way inwards, as if these were cores. Cavity is the opposite. It'll start from the inside of a pocket or inside of a contour and work its way out, as if this was a cavity or a pocket. HM spiral is a combination of the two. It'll actually analyze the part and use core or cavity analyses throughout the calculation of the toolpath. These other tabs are really just for refining the toolpath itself. So under smoothing, I'm telling it to smooth out the toolpath. Here's my max radius. So any line segments, it'll just come out as arcs. Step down, I'm just making sure that I optimize it along the Z-axis. And further options under edit passes. So there's a couple of things here that in a more advanced sense you'll use, but otherwise the default settings are really good for generating a HSR toolpath. Again, this is a roughing toolpath best used for very surface heavy parts, like the one you see on my screen here. There's a lot of arc movements, there's a lot of arcs, fillets. If you had a prismatic part, you might use something like 3D milling or 3D iMachining, and you've seen those in the previous videos. Under link, we're controlling the movement of the tool. So under general, we choose either climb milling, conventional milling, or bidirectional. In this case, we'll just zigzag between the two. Link by area, link by Z level, and link by cluster. These are, again, just ways to better control the toolpath. So for instance, link by area would actually make sure that it completes a complete area in terms of Z all the way down, Z level, before it moves on to another deep pocket or another deep area. So again, more control over the toolpath itself. But once again, the default settings are a good place to start. In terms of ramping, we have the options of profile ramping, helical ramping, and plunge ramping. Once you choose one of these, it opens up the various parameters you'll need to control it. I'm just going to stick with plunge ramping. And again, additional tabs for additional control when you click on the Advanced tab. So if I calculate this, we'll see that we get a toolpath that moves between contour and hatch kind of movements. Essentially what we're doing here is the HM spiral. So in some areas, it looked at it and it machined it as a core. Some areas it machined it as a cavity. So that is the HM spiral, HM roughing toolpath. Using the same parameters, so the same target, the same levels, and all, and same parameters. Essentially, I've just done a save and copy, and we're using the contour roughing. So same tool, same constraint boundaries. When we get to passes, we'll see that there's similar controls, but there's a few differences here because we're doing this as a contour style toolpath. If you remember from the pocketing video, basically contour and hatch were the options you had, and you'll see on the left side here that we both have hatch and contour as our options for this 3D toolpath. So again, I'm leaving 10 thou on the walls and the floor. Step down is 100 thou. Minimum offset is 300 thou, and if I wanted to, I could set a maximum offset. Again, we're doing contour style step overs, so I have further control over that step over. Once again, we have smoothing. We have an option here called Detect Core Areas. And if you look in the bottom left corner, you'll see essentially what that does. If it detects that there is essentially a large core area or an area that it can treat as a core, it'll actually approach from the outside. Under my levels, I have the same Z top, Z bottom, smoothing, essentially all the same sort of parameters. Now, under adaptive step down, we see that the step down of 100 thou is what will be used in this toolpath. But if there's any features of this toolpath that fall in between that 100 thou step, it will automatically insert passes to make sure that we machine those features. That comes in very handy when you have flat areas and very less gradual curves or less gradual tapers. Under link, it's exactly the same. So we have the climb, conventional, bidirectional, link between areas. Ramping is the same. And if we take a look at that toolpath, for the same part, same stock definition, we'll get a contour style toolpath. So you see that there's a lot of movements around the outside of the part and working its way in, a lot more curves in this toolpath. If we switch this to the hatch roughing, we go to passes, we'll see we get the same control over the step over and the step down. Same roughing, same levels. What we do get here is define angle by. So this is similar, again, to what you would have seen in the hatch option of a pocketing toolpath. It is 0 degrees to the x-axis or any angle we choose from the x-axis. Essentially, all the parameters are the same. So once you choose your parameters here, you're really just choosing which direction you like the tool to move. In terms of hatch, we can see that it's got that movement back and forth. Less of a curvature, more of just a parallel to the x-axis or whichever direction you choose. Much as the profile and the pocketing toolpaths, here we have the rest option as well. So if we open up this one here, in the top left corner, I've chosen the rest option, rest roughing. So the target is still the geometry. In this case, I've gone down to a 1/4 inch flat end mill. We're going to use the same constraint boundary. Under passes, you have the same control. So I'll be leaving 10 thou on the walls and the floor. Step down. In this case, my minimum offset, because I'm using a 1/4 inch tool, I set it to just 130. Insert automatic steps, smoothing. Everything is the same. Under link, everything is exactly the same. Now, under edit passes, this option actually exists for all the toolpaths, but it's set automatically here to be used, and that is the stock definition. So it's actually going to analyze the updated stock and determine which material needs to be removed that has not been removed by these previous toolpaths. So that half-inch tool actually machined this stock already and left behind certain areas that only this quarter-inch can get into. So essentially, that's all we're doing here. But this option actually exists for all the HSR toolpaths. So this one I'll actually calculate so we can see what happens. So it actually does calculations, and because I've told it to do rest milling, it automatically defaults to a contour style toolpath. And that right there is the resultant toolpath of this rest milling operation, or this rest roughing operation in the HSR toolpath. Any questions on this or anything else that you see in this video series, you can always call us at 1-866-975-1115 extension 2. You can send us your parts and your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this series. Thanks for watching.